Alright, I'm going to start this video as I usually do with my test equipment videos by looking at Chuck Penson's excellent book, HeathBuilt Test Equipment Products. And I'm going to flip to the special chapter on the Malmstadt-Encke series of laboratory equipment, and I'm going to just dive straight into the part of interest here. I have 4 other videos already that go through this whole chapter showing all the different equipment. Equipment that Heath designed and made in their factory but did not produce as kits, and for the most part is distinct from the kit product line, although there are some parallels. For example, the EU-80 oscilloscope is just a cosmetic difference from their IO-105 scope. Anyway, so here's the product again. That's what it looks like. It's the voltage to current module for the EU-80A. And I do have a video already on the EU-80A. So this module came with this, and it just plugs in the front, and it allows you to convert the voltage output of this into a current output, very low current range output, very specialist applications. And I'm only building it because I want this item to be complete in my collection, not missing a part. So that's worth a little bit of time and effort. Again, there's really not much of a description on here other than that it converts the voltage output of the one thing into a current signal. Alright, I've made a little sketch here to scale with 3/4 of an inch between those intersections and 3/4 of an inch up to the center one there, and the same thing there. And since I expect that the peripheries of the connectors might go out as much as 1/4 of an inch, I've boxed that out as a sort of a zone surrounding these that should be clear. Okay, this is the box I've selected. It's an Amazon item. It's the so-called Limotech aluminum alloy metal junction box, IP67 waterproof, dustproof, small electrical box, outdoor universal enclosure gray. And it comes in a variety of sizes. 2.5 by 2.2 by 1.3, and then up through, was it about 6, 7, 8, 10 sizes up to about 10.5 by 7.25 by 3 3/4 ish. And I've got the smallest size, like I said before, cost about $10. I think it's powder coated. I'm trying to see if there's more on here. So, aluminum alloy material, highly resistant to corrosion. Not that I'm worried about that. More product details. Yeah. They have internal threaded holes, stainless steel screws, a rubber grommet, counterbore holes for mounting, and so on. Seems like an okay product. They have some additional diagrams here. Showing you the external dimensions, internal dimensions, additional internal dimensions, features, blah blah blah. Yeah. Anyway, okay, here's the actual box with the stainless steel screws removed. The lid has a groove in it, and it comes with a length of sort of a silicone rubber, a rope if you will, which can be pressed into that shape. It's a little oversized and you can cut it to length, and then that makes the gasket if you need the gasket. And it actually ends up pushing down on this ridge, essentially compressing it into this groove a little bit, and then that rubber compresses into the hole. It doesn't actually stick out once you've got it all battened down. So it looks like a pretty good seal. It has two deep holes with shoulders on the bottom, at the very bottom, so you can put in screws to screw this up to something. I don't really know why these holes are there at the corners. These appear to be the same holes as the ones that the screws go in for the cover, but why they go all the way through, I'm not sure. And actually light doesn't show through them, so they're apparently blind holes. I don't really understand why they went all the way through. There are two raised platforms there with threaded holes in them, and those could be used, I suppose, to mount some little object or a little circuit board in there perhaps, or you can put a screw in there and then use that to put a wire with a ring lug on it to, you know, ground this box to a wire. So all that's well and good. As for the biggest concern I have about fitting everything in this box, does this have enough depth to fit the 3 banana posts? So here's my little scale sketch. The 2 main ones will be at these top intersections, and they're only a 632 hole, so that can quite clearly fit. The bottom one at this intersection, that one is not insulated from the case where the other 2 are, so I could actually drill a hole fairly close to the edge of this, and some of that hole might actually go into the base a little bit, but I can certainly go right up against it, or maybe even beyond, and just drill and tap that hole and then screw the banana post into there, because that one's just the ground. It should be electrically connected to the metal here in a direct way would be best. So I can do that. That means I can actually, and there's no insulating bushing on this, so it can go pretty close to the bottom here, a little bit like that. And that should leave me plenty of room on the top for those other 2 holes. So I think it'll work. And now just going on the inside, this actually works out where it fits right in between those protuberances there. And again, it barely sticks out, so I don't think I would even have to drill that bottom hole into the base. It can be drilled so it just goes up adjacent to it, and it'll still have plenty of clearance. So it's about perfect. I don't think I even need to cut into these at all. I thought I might have to mill those out, but I think it'll work just as it is. The dimensions probably couldn't be much better. Okay, so there's that. Here's a scale sketch on another piece of paper. Just the outer boundaries. It does line up, and then the depth of it is, like I put, right adjacent to it. I did that when I was selecting the box initially before purchase to make sure it had enough room. The only components that are in this are the 3 posts on the banana side and this one insulated type BNC connector, because you don't want the outer part of this to be connected to the metal box. It has to be isolated. So it has to have room for that on the inside, and make sure the threaded portion of this is enough to go through that thickness. Sometimes you get these and they're only designed to go through like a 1/16 inch thick piece of sheet metal and can't go much beyond, but this one has adequate extra threaded section on the insulator to go through this thicker box, and it does have a nice lock washer there to keep it from unspinning. So that should be pretty good. So the actual portion of this that sticks into the box is pretty minimal. This is a scale drawing of the outline of the switch I bought. That's the outer periphery, and that's the part of it that slides. So it obviously has adequate room to fit in there. You know, if I put this on there for scale, even the outer flange is inboard of these things, if it was even going over far enough to hit one of those. The things that stick into this the most will be the threaded portions of the banana plugs on the inside, but I can actually cut those shorter so they're no longer than necessary, because the electrical connection is just made by putting a ring lug onto the threaded part and then screwing a nut down on it. So again, I can trim those so they only go through the metal a little bit. That leaves most of this space open. So what needs to go in this space? Well, obviously the switch goes in there over towards one side, maybe over here-ish, and it's going to go down for maybe a third of this distance, sticking back down in there. So the rest of this space and space beside it is available, and the only other two things that are in here are the two resistors. Now one of them is quite large. The 1 giga ohm resistor is probably 3/4 to 7/8 of this entire width, but it's narrow. It's just long, but it doesn't take much to the sides. It's just like a narrow tube, kind of a flattened narrow tube, I believe. And then the other one is more like a normal 1 meg resistor. It's just like a 1/2 watt resistor, so no problems there. Now, because I'm going to have to put the switch on the cover and everything else will be bolted to the sides, there's going to have to be wiring in this or you'll never get the lid off. So that's a consideration. But again, all there really is one wire coming from the minus lug going over to the outer side of the BNC connector, just a short length of wire. The other one here is going to have a wire coming up. It has to be flexible and long enough to go to the switch on the cover and get the cover off. And then both resistors are going to connect, I think, down to the center part of the BNC connector, and then go up to the two sides of the switch. So again, there might be as many as 3 wires, short lengths of high flexibility wire, and the resistors are just going to be hanging in there. There's not going to be any lugs to mount them to or anything. I don't think it's really even necessary. I'm debating yet whether I should have the resistors mounted to the BNC connector or if I should have them mounted to the switch, whichever seems to make the most sense when I get all the parts and can visualize it better. I was thinking I was going to have to go in here with my milling machine and mill out some of this stuff, but at this point I don't think I will have to. Well, this answers the question for me, I think. The Heath box was actually apparently a sheet metal box, or at least the cover was sheet metal. The rest of it might have been cast, but from the looks of this, it looks to be very thin walls, so I'm guessing it's a welded sheet metal box. So it does show here both resistors, the big one and the little one, connecting to the center lead of the BNC connector, and then it doesn't show the actual electrical connections here because this is just a parts list identifier exploded view. But the this lead of this resistor will go up to these lugs, and this lead will go to these lugs, and those will have to be done with wiring because this will be fixed to the box, this will be on the cover. I could possibly put the switch in to that side, in which case I would not have to have the wiring and the cover would just come off, but then this is your front panel with those ugly studs on it and all the holes. And I don't really want to do that. I'd rather have the switch go on this side. That necessitates the use of the wiring. Here's the original, or a photo of the original. The switch is over to one side somewhat, probably to facilitate having the resistors in between the BNC and the switch. This is a bigger box than the one I have. I scaled it out, and the original is probably about 3 inches long, where this is only, whatever I said it was, like 2.5 inches, so a bit smaller. Certainly big enough, but not quite as big as the original. And the only writing on the original was kind of a line pointing to one side of the switch and then saying 1 mega ohm, that's the resistance value, and that will achieve a a microamp output on the 10 volt range. And the other one's obscured here, but it says 1 giga ohm, and then this would say a nanoamp in the 10 volt range. That's what would be there. Now to do that, I wanted to do it neatly. Try to do this as nice as I can. so it doesn't look like a bodge job. I visited a local reprographics place that does all sorts of things, silk screening and laser cutting and laser engraving and embroidery and all sorts of things like that. They do some specialty jobs for me, and indeed they do like one-off and small quantity industrial jobs for electrical equipment, so they know what I'm talking about. And what they're proposing to do is, instead of silk screening this, the minimum setup and labor for that would be at least $80. For about $30, they can put on, just roll on a layer of this special ink, if you will, or paint, and then they, it can be wiped off very easily. Then they run the laser over it, painting the image I want for the text, and that basically fuses the paint to the surface here and leaves the rest of it soft, so then they can go over it with water or a light solvent and just wash everything else away, leaving only the text. And so again, for about $30, maybe $35, they said they could do that to this. The problem is if they bodge it, botch the job and have to try it again, they can't easily wipe off the part that's partially fused. So you could easily ruin a cover like this if they're, and they weren't absolutely sure, they don't have any experience doing it on these textured surfaces, but they thought it would work. So to that end, I've actually bought 2 more of these boxes. I figured they'd come in handy for something, and that way if they booger up one cover, at least I've got a spare or 2 around that I can use for that. So the only real machining I have to do on this is drill a hole on one side for the BNC, drill 3 holes for the male banana plugs, make a rectangular cutout and 2 mounting screws for the switch, and that should be the extent of the machining work on this. Now I just have to wait for the banana plugs and the resistors to show up so I can finalize the dimensional design on this. Alright, my DigiKey order came in with the Pomona 3263s. That is these male banana plugs with a 1/2 inch long 632 thread and solder lugs and nuts. I'm also going to put a lock washer on these. They don't come with it, but I'm going to put on a 632 or a number 6 lock washer. So looking at it this way, there will be plenty of the screw going in as far as length. I also have from McMaster Carr a bunch of these nylon insulators. So they have a number 6 screw in the middle and essentially a nylon washer plus the shoulder going through. So those obviously will fit around the lug like that. And somewhere, I don't know what I did with them. Oh yeah, here. I have these phenolic washers that I have a stock of. Now they're actually for a number 4 or number 5, so I ran a drill through those to get a close tolerance hole for a number 6. So this will insulate the outside from the metal case and through the hole, and then I'm going to have to cut that short and then put one of these around it on the inside and then put on the lugs and the nuts. So that will make sure that 2 of these do not contact the case, and one of them I will still put on with the nylon to get the depth right so that the pins all stick out the same amount from the case, but I will not use the shoulder washer, or just the fiber washer rather, on the inside, and I'll make sure to scrape the paint and use a lock washer on there. So that one, the third one, will be connected to the case as desired. Now I've done a little study here. I figured out what the thickness of the bottom of the case is by measuring from the inside and then measuring the same distance here, and that's this line here, That's where the bottom of the case is. And I thought the closest I can get to it and still have the nut rotate without, you know, jamming up against the bottom of the case would be on this line here where my fingernail is. But I also would like this pattern to be roughly centered vertically. This is where the 2 posts will be, and this is where the 3rd one will be. So if I center it vertically, then it ends up being about this high. So that's what this line here is for. It has to line up like this, and therefore I will have plenty of swing for the nut on the inside and still not to be too high up. And I also want to make sure that the shoulders on this don't go up so high that they go above the lip here, so I have to check that out. There we go. Yeah, so it'll come close to it, but it won't go above it. I think that's a pretty good position for this to be. So what I plan to do here is tape this down. I've made sure my dimensions are accurate. I had just laid this out with a ruler. I'd drawn a mark for the center one here, and then knowing that they're on 3/4 inch centers, I just swiveled my ruler around from that point and marked where 3 inches or 3/4 of an inch was, and then did the same, and then checked across. So to make sure I'm even more accurate than that, I used a pair of dividers and put it on my ruler on the indents for 3/4 of an inch, where they're indented for the lines. Got it set up to 3/4, put it right on the intersection, and it's right on the intersection there. Check the same thing here, it's right on there, and then check between, and they're right on there. So these are accurate points for the center of the drill to be. Now I just have to transfer that to the metal, and for that I'm going to tape this template on here and then use a center punch to hopefully get reasonably accurate drill holes. Alright, the template is taped onto the case. Alright. Not absolutely dead nuts on this one. The textured surface made the point want to skip around on there. It ended up being just slightly off, but I can't do much about that now. I think that'll be within the tolerance that these things with their springiness will tolerate. If I have to, I can fudge the drill bit a little bit over in that direction and make it work. Alright, holding it in my small Microlux vise, and because of the tapered sides, this is narrower than it is up here. I just have a appropriately selected drill bit sitting down there. You can kind of see the end of it, just kind of wedging this side up, and then I also had to push down hard on this side to try to get it pretty level according to a bubble level. I think it's close enough. Now if the drill didn't wander too far, and I don't think it did, hopefully these will line up reasonably well. I've cut the nylon shoulder washers, or whatever we want to call them, a bit short, and fitting through there. I do not see the nylon protruding into the hole. Alright, temporarily fit in there. Now I'll go see if they fit the actual instrument. Going up to my wall of Heath stuff. Maneuvering over here in these tight quarters. Yep, fit in there just fine. So I think I got that part done well enough. I've scraped the paint off around the inside of that one post, and I have a few 6 star washers. I really wish I had the external stars, but this will work. I found that I'd made the shoulders a little short on the first ones I did, so they were allowing the bolt part of the prong to potentially go diagonally enough that it could touch the inside of the hole. So now I put them through and cut them with my utility knife right up against the inside while they're inserted, so I'm sure that the nylon goes all the way up to the end of the hole. And actually I cut that one slightly diagonal, so I have to trim it a little bit more. Alright, there's everything in there. Seems to have worked out so far. Alright, doing a sanity check. I've got one side of my continuity checker in the threaded hole in the case, and I'm going to tap it against the solder lug here. Got that. Tap it against this lug, nothing. Against that lug, nothing. Oops, I was hitting the center one again. There. So I've got my ground connection going to the case and the other two not going to the case or to each other. And I just ran upstairs and did a second sanity check, making sure it still plugged in easily into the instrument. So that's good. And I can get at the solder lugs on there. I have a solder lug on here because I'm figuring that's how I'm going to make the ground connection to the cover. Otherwise it'll be dropped on the floor, and you know, even whether or not I use the gasket, it's still powder coated. I need to have some way of grounding it. So once I make the cutout in here for the slide switch, and I'll make sure that the mounting hardware for the slide switch is connected through the steel frame of the switch and then through scraped off paint with a lock washer here. I'll make sure that that's a ground point for the cover, and I can run a short length of wire from that center one up to the cover and thereby get that with its ground connection. Now for the BNC connector, I just have to figure out what the diameter is and then go ahead and drill a hole for that. This should have a flat on it, and that's always a problem I have. I don't have any tool that does the flats. So what I usually do with those is I'll make the hole round, and then I'll cut a thin piece of sheet metal that just goes along the flat side and glue it to the case or something to discourage it from turning. So making a flat in that manner. Okay, using my step drill to put the hole in, and I have a nice close tolerance. It doesn't really shift sideways, but it goes in easily. I think it'll be best if I orient the flat facing this way, so best accessibility. So I'm just going to get a thin piece of metal and maybe make it so it goes right up to the whatever these things are, these protuberances, and then lay across the top of that. I think that'll probably work pretty well. Alright, I've just made a aluminum plate that goes in there. I just drilled it smaller with a step drill and then used square and round files to just sort of hack it out. It fit a little bit loose, so I put a little bead of super glue in there and accelerated it to fill in the gap so it would not wiggle at all. And it's quite stable here. So now I can put on the real mounting hardware. Okay, that's in there now. So I think I've done all I can do with this case. There's obviously ample space in here for the switch, which should sit down about in this area close to these. And the one resistor, the 1 giga-ohm resistor, is pretty much the whole length from here to about here. But there's lots of space down below. I can kind of run its lead down there and kind of lay it along the bottom. And the other one's about the size of a 1/2 watt resistor, so there's lots of room for that. So I have no doubt that I can fit everything in here. Now I just have to wait for the slow boats from China. I don't know how Jameco could take my accelerated, or what's the word I wanted. I paid them extra to expedite the shipment, so it's an expedited shipment. But they must have been working on partial hours or something, because it didn't even get shipped for several days, and then we were into the, into Christmas. So now it's just starting to move. I'm gonna have to wait till next week before I get these remaining parts. If I'm lucky, I'll get the resistors tomorrow, but I won't get the switch till next week. Alright, well, the United States Postal Service came through for me, and my Jameco order came through today instead of 3 days from now. This is a 3 amp 250 volt or 6 amp 120 volt AC rated, DPDT, 2-position maintained selector switch. Here it calls it Pronic or Pronic. The Jameco invoice says it's GC Electronics, made in the USA. Doesn't say that anywhere on here, but maybe it's true. Hard to believe that anybody would make these in the US, but okay. Anyway, I've tested it out. It seems to have pretty clean contact switching. No issues with the switching. Certainly should be adequate for this task. It needs to be DPDT, according to HeathKit, for the lowest noise switching, so they actually parallel up the contacts. It's not for increased current handling capability. It's for the lowest resistance and the most, the cleanest overall switching action in something primitive like a slide switch. So as far as depth goes, it's certainly no problem. All I need is enough room in here for the resistors to go underneath the switch. So certainly if the switch is mounted up near the top somewhere, there's still plenty of room down below for the resistors. And there's certainly, if I put it about here so it clears the BNC connector, or over here so it clears those, either way, then there shouldn't be any problem. And Mauser has delivered their shipments, so it's supposed to be 0.1%, I believe, 1/2 watt 1 mega ohm metal film resistor, and the tolerance band is neither gold nor silver, so it's one of the other ones. So that's 1004, right? And of course the 1004 refers to 100 followed by 4 more zeros, which is in fact 1 mega ohm, so that's correct. And then the other one, and by that's a Vichy part, and this is also a Vichy part, thick film resistor, through hole, blah blah blah, 1 giga ohm, 1% again, and it's in this factor, long and flat. The actual part is marked Dale, which is a venerable resistor company, so I suppose that Dale and Vichy are part of the same company now. Anyway, as I had planned, there is just enough room in here to fit this resistor like this, or laying flat down there and insulated kind of diagonally. I think I'll end up just doing something like this and then insulating the leads. I may do something in the way of a clip to kind of hold it in position. I'm thinking that I might use that tapped hole there with a little bracket of some sort to kind of clamp it in there so it doesn't, you know, wobble around inside the case. Alright, I put in 2 holes for the mounting screws. The switch will go underneath, so the screws will go in from the top, and I have some nice 440 slot head screws that resemble the original HeathKit ones. I've got a short one and a longer one I'm going to cut down. That's the one that's going to go through the grounding, become the grounding stud for the cover. These are clearance holes for 440, close clearance. And the sliding cutout area needs to be 1/4 inch by 1/2 inch. Good old American made designs when everything falls to even inch increments. So I've got the cutout roughly penciled in there and 2 1/4 inch holes drilled, so most of the material's already removed. Now I have to go at it with my files. I could mill it out, but the amount of setup time it would take, I think it's easier just to do it with the drill and the files. Alright, got a nice rectangular hole there. The shorter screw comes through just about as much as I wanted. The other one has a little longer poke, so I can get a lug around it and solder a wire on, like that. Probably drop a number 6 lock washer over it. I don't have anything smaller. And then the 440 nut, and that should do the trick. So I think that'll work out just fine. Alright, I made a little aluminum bracket. It'll go onto that one flange, and it turns out it's a M4, you know, times 0.7 screw thread, and that's the same size that is provided to hold down the corners of the cover, so I just borrowed one of those to make sure the thread size was right. And the idea is that once I get a shorter screw of the right kind to go in there, it'll clamp down that tab, and then that'll hold this bracket in there, which goes down to the bottom and kind of goes up and touches this protuberance here, but it comes short of hitting the leads on the resistor, and it allows a little wiggle room, but it doesn't go very far. It's slightly loose in there, so I think that'll be just about perfect to hold that in place. Alright, here's the other bracket. The first one will go up here, this one will go here. It just goes out and then it has this little trough on the end, into which we'll lay this resistor, and I will secure it with a little glob of epoxy probably, so it's sort of sitting like this, and the one lead that remains with the box will go up and connect to the middle prong on the BNC, and the other side will be cut short and hooked up with a short piece of wire that will go up to the switch on the cover. Likewise, this guy, the lead that's over on this side, will just go over and similarly hook into that center BNC lead. The other side will be cut short and have a short wire going up to the switch on the cover. So all I really need to do is find out now if the silk screen shop that I was going to use to put the silk screening on this is open tomorrow. If they are, I can get this silk screened and still finish the box promptly. On closer inspection, I found that there were a couple of tiny places around the edge of this cutout that the paint had chipped, which suggests to me that it is not a powder coat, because I don't think a powder coat would have come off that easily, but maybe I'm wrong. Anyway, just to seal those edges and also to put a little paint around the cut areas that were just bare metal, I touched it up with a little bit of this old bottle of Tester's neutral gray enamel paint that I had laying around for years. I had a couple similar colors that would have worked. This is actually just a slightly shade darker than it should be. The another one that was slightly lighter, it probably would have been a better match, was dried up, so I figured it's barely noticeable as it is, so I'm good with it. I've scraped the paint off of the inside around the switch, so when the switch is bolted down there, its case will become part of the shield that the cover is part of. And then I'm going to sandwich in this ground tab so I can solder onto it. I was going to put a couple of washers and a lock washer, or a couple of nuts and a lock washer on the post, but it's too close to the rest of the stuff on the switch, so I can't actually turn the nuts, so that won't work. So I'll do this plan B approach. Alright, all the wiring assembly work is done. I've got a red lead coming from the plus, going over here to the center of the DP/DT switch, and I have the black lead, or the minus one here with a black lead, that just snakes around the bottom and goes to the outer terminal of the BNC connector, but it is not connected chassis ground because it's an insulated BNC connector. So the negative here all the way through is floating relative to the chassis, which is only connected through that third lug down there, which has got the paint scraped off of it. It has a lock washer, so that makes direct connection to the chassis at that point, and that is from the third pin. It also has a green wire going over to a solder lug, which is pinched between the switch frame and the paint scraped off section of the cover, so you have continuity for the shielding. The center of the BNC goes to both the 1 gigaohm resistor and to the 1 megaohm resistor down there. And then the 1 meg comes through the yellow wire and goes to the 1 microamp side of the switch. The 1 gigaohm resistor goes through the orange wire to the 1 nanoamp side of the switch. And I've made a tiny little schematic of it on a post-it and stuck it in there. So neither resistor are going to roll around. These here are firmly connected to the BNC connector, so they're not moving. These sides are more exposed, so I did put heat shrink tubing on them until they got onto the insulated wire, so there's no exposed connections there. And there's the box closed up. Don't have the cover screws in it yet. Okay, a test. I have my bench power supply set to 10 volts and connected up to these two terminals. I have verified that it is within 1/100th of a volt of 10 volts, so well within tolerance of this device. And I have a BNC cable going over to the test leads on my best or highest resolution milliammeter. I have the switch in the milli or a micro amp setting, so 10 volts should equal 10 microamps. When I turn the power supply on, 0.01 milliamps, so yes, 10 microamps. It's right on the money. And now if I throw the switch here, we may not even be able to read much here, but it should go to 10 nanoamps. And yes, it's below the ability of this meter to read it. So while my instrumentation here isn't sensitive enough to read out, it would be 1000 off of that, so it would be a 1 over in the position where the M is now. That's not enough to roll up to a 1 here, so this is the best meter I have for this, and it won't even register it. But I'm sure it's working. So I think this is a success. All I need to do now is see about if I can get a decent silk screen on this. Alright, just so that I can prove it works instead of assuming it works, I have the rig set up again, although I did take the cover off. And I have my resistor decade box in series with a trim pot that's dialed into 10 to 1 mega ohm as close as I can dial it. And I've got the 10 volt power hooked up, and you know, I'm reading about 10 millivolts, so that's what you would expect across that 1 meg resistor. So it is working. It's not real accurate here because of various tolerances, but at least it's not dead. I don't have a bad solder joint or something. Well, some disappointing news on this. The Repro Graphics company that I work with experimented not with this piece, but with the unmolested version. Tried several techniques. They could not get a silk screen to work well on it. They didn't use my pattern, they just used some test patterns that they had, and this surface here wasn't taking, it wasn't sticking very well. Whatever surface this was, it didn't seem to get a good bite, and they could, you know, just like wipe the stuff off. So they said, well, they would go to the laser printing technique, and they tried it on that same piece, and the emulsion that they would put down and then laser fuse was not getting the right bonding characteristics either, so they didn't even proceed with it. And so I've gone to plan Z. I'm past plan A, B, and C. And what I'm thinking of doing is just to get some sort of a label on there that looks half decent. Is kind of like this little sketch I made. I'm going to cover up like this whole middle section just inside of these recessed screws with a label, which I'll design the graphics for and print out on my print to last laser printable plastic film, and then just stick it on there and cover that up. That'll also make this area look a little better. I don't think I'm going to have any success at color matching this, so instead of trying to get the label to match the surrounding colors, I think I'm just going to make it a contrasting color and leave it at that. I thought about repainting this entire lid, which I could do, but then it won't match the rest of the box, which would look odd. And I don't want to repaint the whole box because I've already got all the wiring work done. I'd have to unsolder everything to remove the banana prongs and the BNC connector. It's like, it's not worth it. I just want to get something neat and functional at this point. So I'm going to leave all this alone. I'm going to design a new label, print it out, adhere it to this with some permanent adhesive, and you know, then trim out the holes and the rectangular cutout, and then reassemble it. Alright, I've laid out a new graphic in my page layout software because the positions were really odd increments of any units. I just measured on the original plate where I wanted things to be, measured them to the nearest 32nd of an inch, positioned these grid lines not grid lines, but these alignment lines at those positions, and then just dragged and dropped the text and visually aligned it. And then here's a copy with the lines removed. Doing a test print on just regular paper, and then holding it up to the light, I can see that the text is positioned appropriately for the physical switch. There's a shadow there that makes it look a little further down. It aligns better the straighter on I look to it. So I think that'll be good. And it can be white. I'm not even going to try to match that gray color. Well, I lied a little bit. I decided to try it anyway. And of course I could not find a match. I think this will work, and it's less, it doesn't jump out as much as having a white label. Yeah, I can live with that. I tweak the position of the text a little bit, and I think it's pretty good now. Now I'll just print it on the indestructible paper. Alright, and now I've got it printed on the 3M print to last paper, which is basically the same as the Xerox Never Tear paper. I have a large stock of both. I printed it on the matte side. It has a gloss and a matte side. I thought it might match better, but I'm also going to try it on the gloss side with another sheet and see which looks best. Alright, there's the beauty shot.